Hi there, welcome back to MA211. We're going to start talking about second order ODEs. And before you attempt this worksheet or before you finish watching this video, you really need to read section 3.3. I'm going to mostly do example problems. Section 3.3 is pretty straightforward to read. So between today and tomorrow, you need to be reading section 3.3 to get the idea behind these problems. So I'm assuming that you have read 3.3. If you've read 3.3, then you know if I want to solve this differential equation, y double prime minus 3y plus 2y equals 0, I should write down the auxiliary equation, which would be r squared minus 3r plus 2 equals 0. I should try to find its roots. This one's roots I can find by factoring. This is r minus 2 times r minus 3 equals 0. Oops, r minus 1 I meant. R minus 1. Okay, so the roots are 2 and 1. And from that, I can build the general solution. Y of t equals c1 e to the 2t plus c2 e to the t. And that's it. So let's try another one. Let's try to solve y double prime minus y prime minus 6y equals 0. The auxiliary equation is, let's see, that would be r squared minus r minus 6 equals 0. This one I can factor as r minus 3 times r plus 2. So we have roots 3 and negative 2. And so our general solution will be y of t equals c1 e to the 3t plus c2 e to the negative 2t. Okay. Let's see again the auxiliary equation for this problem will be r squared plus 6r plus 8 equals 0. That one should factor as r plus 2 times r plus 4 equals 0. So we have roots negative 2 and negative 4. So our general solution is y of t equals c1 e to the negative 2t plus c2 e to the negative 4t. Let's see, how many do I have here? Okay, let's try one more of these and then we'll try maybe something a little bit different. Okay, so this problem, y double prime minus 4y prime minus 12y equals 0. We have auxiliary equation. People also call this the characteristic equation. And that's going to be r squared minus 4r minus 12 equals 0. Let's go ahead and we can factor that as r minus 6 times r plus 2 equals 0. So we have roots 6 and negative 2. And so we have a solution, y of t equals c1 e to the 6t plus c2 e to the minus 2t. Okay, let's go ahead and skip down a little bit. I didn't leave myself room to work here. So I didn't leave myself enough room on the other PDF to do this, so let's try. I want to solve this third order ODE. I'll write down the characteristic equation. That's going to be r cubed minus 6r squared plus 11r minus 6 equals 0. And now you want to solve this cubic equation. I am going to give you some higher order equations like this. Expect you to be able to solve them you can usually, though, the roots will be straightforward. So for example, here you should just guess a couple of easy roots, and I'll always have an easy root in there. So here you can see that 0 is not a root, but if you check, you can see that 1 is a root, because we'd get 1 cubed minus 6 times 1 squared plus 11 minus 6, and that is indeed equal to 0. So 1 is a root. All right. And so then now you know that this polynomial on this side, the left side, you know it factors as r minus 1 times something. Try not to mind my dog if you can hear it in the background. Sorry about that. Let's see. So now you want to factor that polynomial on the left-hand side. You know that r minus 1 is a root. You can do polynomial division or something like that. I expect you to know how to do that. So let me see. You want to take r cubed minus 6r squared plus 11r minus 6. Divide by r minus 1. You'll get an r squared here. So that's r cubed minus r squared. You subtract, you'll get negative 5r squared plus 11r minus 6. And so now you need a minus 5r here. Minus 5r squared plus 5r. And subtract, and you'll get a 6r minus 6, and so you get a plus 6 here. And that's 6r minus 6, and this divides evenly as it should because 1 is a root. So this left-hand side is now, you know, it's r minus 1 times r squared minus 5r plus 6 equals 0. You can factor that left-hand side. Now it's r minus 1 times r minus 2 times r minus 3. So you've got 3 roots. They are r equals 1, r equals 2, and r equals 3. And so your general solution is y of t equals c1 e to the t plus c2 e to the 2t plus c3 e to the 3t. And that's it. All right, let's move on a little bit in the other PDF. All right, we also know that things depend on what kind of roots we have. So if I take a look at this equation, I want to write down the characteristic equation r squared minus 6r plus 10 equals 0. That one isn't going to factor for you. We should try to use the quadratic equation. So we know that r is going to be 6 plus or minus the square root of 6 squared, which is 36, minus 4ac, so minus 40 over 2. So that'll be 3 plus or minus, let me see, this will be the square root of negative 2 over 2. So that's going to be 3 plus or minus I. Okay, and so now we can go ahead and say that our y of t, we can write it as c1 e to the real part of the roots, 3t, cosine of the imaginary parts times t, so cosine t plus c2 e to the 3t sine t. Let's try another one. So this one, the characteristic equation would be r squared minus 8r plus 20 equals 0. Again, this won't factor, so let's try to use the quadratic equation. We'll have r equals 8 plus or minus the square root of 64 minus 80 over 2 again. So that's going to be 4 plus or minus 64 minus 80 is 16, so that's 4i divided by 2, that's 2i. So those are our roots, and so our general solution is y of t equals c1 e to the 4t cosine 2t plus c2 e to the 4t sine 2t. Let's try again. Let's see, our characteristic equation will be r squared plus 4 equals 0. Of course, you could just move the 4 to the other side and solve, but let's go ahead and say this will be r equals negative b, so 0 plus or minus the square root of 0 squared minus 4ac, so minus 16 all over 2a. So this will be, what should this, oh, so that'll be plus or minus 4i over 2, so that's plus or minus 2i, just like you would think if you moved the 4 to the other side and then took a square root. So then we have roots. Don't forget that the real part sitting here is 0, so we'd have y of t equals c1 e to the real part, 0t, cosine 2t, plus c2 e to the 0t sine 2t. And we can simplify that to c1 cosine 2t plus c2 sine 2t. Okay, and let's go ahead and try one more complex root case. So once again, I didn't have enough room on the other sheet. Let's try this again. Our characteristic equation would be r cubed plus 10r squared plus 13r minus 74 equals 0. Just by guessing, we can find that 2 is a root. So then we can do polynomial division, and we can find that this left-hand side factors as r minus 2 times r squared plus 12r plus 37. So now we want to find the roots of this guy right here. We can do that with the quadratic equation. We'll have r equals negative 12 plus or minus the square root of 144 minus 4 times 37 is 148 over 2. So that's going to be negative 6 plus or minus, this will give me 2i. So we've got roots, r equals 2, the original one that we used to factor, and then we've got negative 6 plus or minus 2i. And so our general solution is y of t equals c1 e to the 2t plus c2 e to the negative 6t cosine 2t plus c3 e to the negative 6t sine 2t. And that's it. We will do some examples of repeated roots next class. So